The chip, chip, chiplet ecosystem gains momentum with the Intel and TSMC MediaTek backing. Joseph Chan, the leading semiconductor companies, called for a stronger adoption of the open chiplet standards at the OCP APEC Summit 2025 in Taipei, highlighting the growing industry consensus around modular architectures and open ecosystem and found the foundation of the future data center and high-performance computing infrastructure. Industry converges on modular solution. As AI workloads continue to escalate, traditional monolithic designers approaching the physical and economic limits. The industry participants at the summit agreed that a modular chip architecture offers viable alternatives, but only if we built on open, certain operable standards. In a breakout session titled Innovation with the Program Plays Chiplet for Next Generation Computing Chip Universal Chip and Interconnect Express UCI is Dambarat Das Sharma, Inter Senior Fellow and Chair of the UCI Consortium, described the UCIe as an open and package interconnect standard intended to serve as a PCIe for chiplet. Since the Intel dominated the initial specification in 2022, and the consortium has extended to over 140 members, including TSMC, NVIDIA, Samsung, and other key players. Key MediaTek and TSMC champion open standard. The theme of the ecosystem-wide collaboration was enforced during another panel titled Chiplet Technology and AI Era Opportunity Challenges, moderated Eric Huang as Vice President at Digital Times. CK Peng is Senior Marketing Director of the Marketerial UCI resolved long-standing compatibility issues before UCI chiplet couldn't connect to my ASIC. Peng noted, we are happy to see and understand that more openness will drive more innovation. Mr. Shang Yi Ho, Director of the High Performance Packaging Integration at TSMC, emphasized the manufacturer benefit of standardization, drawing a comparison from a JEDEC CHBM memory specification. Ho said they do not standard component create unnecessary complexity for foundries. Custom interface is a nightmare, he marked, adding that TSMC addressing these challenges through the 3D Fabric Alliance and other collaborative initiatives. Supply chain and design challenges persist. Mr. Leon Chao, Senior, the director at ASE, is highlighted the operational concern that persists despite the progress in standardization. She pointed to the need for a trust-related quality assurance framework, asking how do you guarantee the unknown could die. He also raised the question around managing the supply chain securely in multi-vendor environment. From a design perspective, Tony Lin, as Vice President of Sales and Southeast Taiwan, said the adoption of the chiplet architecture demands a new generation of the design tools. He called the standardization 3D assembly design kit ADK and a simulation performance that enables chiplet from the different suppliers to validate it together. While a fully interoperable chiplet ecosystem is still in the early stages, discussed at the OCP APEC Summit 2025, the rebuild growing industry momentum toward building a scalable and open chiplet as a marketplace. The Open Chiplet Economy (OCE) is an initiative by the OCP and to foster an open ecosystem for chiplet. Its vision including establishing a chiplet marketplace, enabling easy modular design and creating standard interfaces and methodology. The agency facilitated multi-vendor chiplet solution to rapid technology adoption through the open innovation and community collaboration. The chiplet design is basics for engineers. The world is experienced insatiable and rapidly growing demand for artificial intelligence, AI, and high-performance computing HPC applications. Breakthroughs in machine learning and data analytics and the need for faster processing across all industry fuel this surge. Application-specific integration circuits, ASICs, typically implemented as SoC devices, are central to today's AI HPC solution. However, traditional implementation technologies can no longer meet the escalated requirement for computation and data movement in the next generation system. From chip to chiplet. Traditionally, the SoCs had been implemented as a single and large monolithic silicon die previously in individual packages. However, multiple issues manifest as designers push existing technologies to their limits. As a result, system houses are increasingly adopting chiplet design solutions. This approach implements the design as a collection of smaller silicon dies known as chiplets, which are connected to the integrated into a single package to a form of multi-die system. For example, NVIDIA's GPU Technology Conference (GTC) has grown into one of the world's most influential events for AI and accelerated computing. Held annually, the GTC brings together a global audience to explore breakthroughs in AI, robotics, and data science and healthcare, autonomous vehicles, and the metaverse. During the GTC 2025 keynote, NVIDIA President, co-founder, and CEO Nancy Huang emphasized the need for advanced chiplet designs, stating, "The amount of the computation we need as a result of the agentic AI, and the result of reasoning is easily 100 times more than we thought we needed in this year." Chiplets are here, and they are reshaping everything. From AI to automotive, the industry has moved beyond debating chiplet to the building at scale. The chiplet era is underway. Working through the Moscone Center in the San Francisco during the 22nd DAC, one thing jumped out at me that reality was impossible to ignore, not just in the technology demonstrations, but in the conversation happening between foundries, IP vendors, OEMs, and design houses. We moved from this asking if the chiplet will scale to the collaborative moving to how we design, validate, and deploy multiple vendor systems across the integrated ecosystem. The shift in tone from the hypothetical to hands-on was just as clear on the stage at the timed Future of the Chiplet Summit at the DAC, where I had the chance to give opening remarks and later join a panel of the industry leaders. Across both sessions, I shared what I see as the three key areas we need to focus on if you want to move the chiplet from the bespoke engineering project to the scalable industry practice. The three pillars of scalable chiplet adoption. To unlock the full potential of the chiplet, we must commit to the three foundation imperatives. And make it easy for software developers. Elegant hardware is meaningless without a scalable software enablement. Specifically, software must remain stable across the multiple IP generations. Developers must be able to program, provision, and deploy on chiplet-based design without complexity. That means defining common protocol as modular firmware and consistent software interfaces. 2. Build reusable silicon across the supply chain. Today's most chiplet designs are internal to a single vendor, but real scalability comes when chiplets become a product. Reusable and interoperable and composable across the different design points and even generations. That requires a deeper integration between the foundries, IP vendors, packaging partners, and OEMs. 3. Advanced holistic system-level standard. Interfaces like UCIe had made a huge stride, but they only solve part of the puzzle. The system-level specification, how chiplets communicate, boot, share memory, and expose telemetry, are where we true interoperability lives. That is the vision behind the ARM's chiplet system architecture CSA, and now supported by over 70 partners. Low power, high performance. When standard enables chiplet, nobody wants to stand out until the lack of them inhibits the development of the solutions that they need. That is often too late. Semiconductor industry engineering sat down and discussed the need for a standard to enable an ecosystem for chiplet with market Mark Kumar, Vice President of Technology of the Marvel, Letizia Giuliano is Vice President for Product Marketing and Management and Alpha with Semi. He is lead HS segment leader of Keysight. As Mike Big Posner, Senior Product Group Director of the Cadence Computer Solutions Grouping, and Bob Kruger, Product Management Director at Synopsys Multi-Die Strategic Solutions Group. What follows is excerpted from a roundtable discussion held this year at the DI Automation Conference. Part one of the discussion is here, as part two is here. Let's see. In the software IP era, the ecosystem was helped along the creation of the standard body. The Virtual Circuit Interface Alliance that oversaw that emerging industry and helped put the necessary standard together. Why are we not seeing the level of the cooperation within the industry now? Solving the problem collectively rather than everybody trying to do it on their own in little groups. Giuliano. It's because of the time to market and with the way we need to act these days. It does allow us to get together and standardize. We are moving too fast to let a body or standardization effort to do something. We don't have time to do that. SE. Does it mean that the industry has to settle on the de facto standard quickly? Giuliano. What's happening is that we build a solution, and after the solution is built, we build a standard around it for the followers. We are going to the pioneers do what it's done, and then the followers are going to get benefits from what we standardized. I'm positive there are some bodies that are working very well. OCP, JEDEC, or UCI and others, they are working toward it, but it is slower than they used to be. Posner, you nailed it. You said each of the organizations out there today are solving a vertical. They are solving it for their application. Not everyone can spend time solving the automotive challenges. The IME automotive group is solving those. Someone else is solving the data center problems. They don't have time to look at what may be good for everyone. But I believe that they will converge over time. Unfortunately, that will be when de facto standard will come out. Let's see. When nobody is just even trying to solve the problem as a problem today. Quemble. One thing that worked rarely for HBM was standardized through the JEDEC. Everybody gets together and argues about literally everything. Where is every pin located on interface for an HBM? What is the example form factor that you can use that makes something that are three different suppliers can build, and you plug into your interposer, and it will probably work. And we are missing that for other applications. In our conversation last year, we talked about the need to define a bunch of sockets. For each of those, we must get to a point where we can standardize it to the level that HBM is standardized for this chiplet application. This is how we make progress. The downside is it just takes too long to go through standards to meet the pace that we need from chiplet today. Lee, the industry can work faster than before when we get the generation of the standard. Kruger, PCI 5, 6, and 7, and now talking about 8. It's all going faster. And the first each took a few years. Now each is done in less than in 1 year. The one standard that is our golden child is for this JEDEC standard for HBM, but I don't perceive that rapidly evolving as quickly as other things. HBM is alone the lowest common denominator solution. If you look at the HBM provider, they each offer special features. One says we can go a little faster than the JEDEC spec. Another has each XYZ feature. So the JEDEC have to pull everyone together. And for a company like Marvel, that is great. You can multiple source and you can known as long as you're following the JEDEC. You have a minimum level of operation performed by each solution, but I guarantee that your engineers will then say that if you And if we use a particular HBM solution, it'll enable this extra mode. Haven't the IP provider always done that? Posner, that's true, but it is worse now. Going back to the founders, they each have differentiated packaging. They talk about the standardization, but there is no motivation. I'm not seeing any motivation for them to standardize around packaging because they see that as they're differentiated. They don't want anyone to move out for their ecosystem. They want everybody in their ecosystem. We're challenged with that. They see it as the next frontier. Standardization only happens when the user and vendors are divided and they come together because they both need standardization. But when users and vendors are arranged vertically, there is no need for standardization. I'm very constructing something that I built myself. Maybe with partners, I'm doing it all myself. There's no users and vendors. For memory, we have a memory vendors and we have the users. So they have to come together and standardize it so that they would have something to sell, at least at a compliance level. But for chiplets, we are not at that point because we are moving too quickly. Maybe there are applications that maybe benefit from the standardization of well-defined chiplets. But the first users are going to be customer users. And then for future applications, maybe the FPGA is a good example. Or maybe automotive would be another one that really requires standardization. Most of the ecosystem are closed systems, so even if they are not being building everything themselves, that they are defining specs, and then they ask about the standard, and they ask if you beat that. Can you do something faster, lower power, what have you? I don't want to come to the conclusion, but maybe for some application there are chiplet marketplace and ecosystem. But for the application, they will be on their own, and it will be remain or close. What can we expect to happen over the next year? If we meet again in the 12 months, what will have changed? The last year was DFT, but it's really hard to predict where we are gonna see the movement. Maybe it will be a summer. Chiplets are another way to delivering IP. If you are gonna see a move up the curve of the people who went from buying IPs to buying the maybe subsystems, maybe buy more service. Since we have to think about not just as an IP protocol, but now as chiplet is gonna work in the larger system. We have to provide a full delivery for the software and other aspects such as power. We need to define how we offer most value to the customer, not just for this chiplet and IPs, but also how it interacts with the rest of the system and help customers deal with that challenge. Lee, we will see progress in two areas when it comes to solving power issues, more specifically how the solutions truly take in the migration to become the three-dimensional. This is vital for thermal issues, and most of the new problems are related to power. How do I deliver 1,000 of the amps, making sure the system performs the year one? This is where I would like to see us to making progress, being able to actually address a lot of issues. The other area is the increased predictability, including system level performance of chiplet. That is a good way for us to be able to continue to these challenges. Liana, I hope to see progress on ecosystems. I hope to see more application-driven ecosystems where they solve the problems for their domain. And some of them may also be useful in other areas. Different data interfaces for different applications also would be good. Cool. Yeah, we would like to see our link layer that works for chiplet other than you use CIE. One of the things that you said last year that you had never managed to reuse a chiplet. Are you any closer to the study today? That has changed. That is why I refer to the chiplet as being the tail. As the ways to go, we have scenarios where we can reuse chiplet. I wanted to point out the distinction is not easy as having a chiplet that
can plug into somebody else's system center that was pre-planned. New observation from me is that when we making chiplet for users, it becomes what chiplet can I get, and because there's no unified standard for how I plug them together, exclude that hold them together, that becomes a custom part of the product. That's really hard. I'm sure you see the challenges, but it's one thing that has changed since last year. Juliana, you have to go to a flow of integrating chiplet and learning what you need to do to make something future-proof or backward compatible. You need to go through the data flow. Start with this is my checklist for next to make it future-proof. It's just surviving things. Otherwise, it's huge investment for every different application. Cost, customization, configuration. If you can't get there, why are you doing it? In a year's time, we will have the same conversation, but there will be examples of mini ecosystems. The first proof cases of missing and matching chiplet from the different providers are still based on pre-learning. When you jump to start an ecosystem, you still have to design an ecosystem. We won't be at the stage where you can just mix and match, but there's will be ecosystems where you can design based on a known chiplet specification. Presumably, you'd have to qualify that within a single foundry. Not necessarily, we are beginning to see some level of convergence that is a key component to making chiplet work, so that foundries want to lock you into one node, but you don't have to have your own whole chip from a single foundry. There are use cases that are force us to do that when you start to looking at a GA3 ADC or DAC mixed signal optical. That's already happening. I'm amazed about how much have moved in the last couple of years. The tempo has definitely increased. You talked about the reusable chiplet. How far are you toward your ultimate goal of completely reusable chiplets? That depends on you. That depends if you mean a plug and play, or if you have to plan for it. Right now, that we are perhaps 20% of the way there, less than 50% for sure. Once you go through the couple of times, you learn how to make it. As an industry, we would benefit from the company that build a relatively straightforward design IO chiplet, and they get together and say, let's say the target for dimensions, pin location, interfaces, link layers. If we got together and did the full application, maybe it's even something that nobody cares about much about. That would be a difference. If we could together one of the key players in industry who are interested in achieving some culture standard organization and headshot. Here's what we do, then here's what we tested. Then it could pay the huge dividends. But we don't need to eat a real application because that nobody cares about the application enough to compete with each other. We just want to eat out of the goodness of our hearts. Oh, says Brian Bailey. UCIe 3.0 doubles data later for 2D chiplet. The UCI consortium released the 3.0 version of each UCI open standard, designed for a high-speed interoperable connectivity between the chiplets in the same page. The new version of the standard is fully backward compatible with the early version. UCI chair Debra Das Sharma told the EE Times, we want to make sure that things move in a backward compatible manner so people's investments are protected. Das Sharma said, we need to deliver the best power performance cost metric that people can get, and then of course we have to continuously innovate. The key to making sure the standard keeping deployed is to continuously innovate. Headline communication speed for planar communication via UCIe S2D and UCIe 2.5D and have been doubled to 48 and 64 gigatransaction per second respectively. A lot of bandwidth hungry application, primarily in the IP space, but also in HPC and other areas, show line limited. Thus, Sharma said, whatever show line you have is fixed by the die size, but we need to deliver more bandwidth, and the way to do that is double the data rates. Denbra Devendra Das Sharma, source of UCI Consortium. As a leader of the change of the BER rate BER for the 64 GT post-SEC, mode was registered from the 10 power of minus 15 to 10 power of 12 minus 12 minus 12. Thus, Sharma said that this isn't a problem as external interconnected the PCI and USB use 10 power minus 12 and 10 power minus 6 with the forwarded error correction. This ahead of the needed to be used to increase the data rate. At the request of the DSP provider, support for continuous transmission protocols has been added to the new version of the specification. The goal is to enable interrupted data flow between the SoC and the switch plates in the wireless infrastructure, radio, and radar systems. The issue has been a mistake between the ADC frequencies and link frequencies. This previously required two synchronized PLLs, which could introduce noise into noise-sensitive circuit. The new version of the UCIe maps ADC and DHC transmission protocols onto existing raw mode, allowing links to operate at the same data rate as data generation. Enhanced runtime recalibration and L2 state at the chip power saving state to help save power, as other features help with the managing firmware download across multiple chiplets and the new function to prioritize transmission of the low latency messages over the sideband and features to help in the event that an emergency throttle or shutdown is needed. Thus, Sharma said that the new features for standard are prioritized based on a combination of how straightforward they are to implement and how useful that would be. Some things have no longer lead times, so of course we are working on them, but some things may not be ready for prime time, he said. Even if a feature misses a major release, we will keep in the bucket. That's the nature of the beast. Some are harder to tackle and some are easier from a time perspective. Ultimately, it's a democratic process, Sharma said. In the end, it depends on how much bandwidth people are willing to spend and how many review cycles are going to happen. The standard isn't tied to any particular release cadence, as last Sharma said, rather than release to reflect demand from the member companies. Okay, today, thank you for your time. See you next time.